Hi everyone, this video should help you with the Cambridge for Mod 9. Mod 9 is on similarity, so they're talking about similar triangles, similar ratios, similar polygons. So let's get started. The first one talks about y varying directly as a function of x squared. So in general terms, what that means is that y is equal to kx squared. Okay, so if they're going to give you several scenarios associated with it, you could actually look at it as y over x squared in your first scenario. Whoopsie daisy, I wrote x2, is going to be equal to y over x squared in your second scenario, and then all scenarios through that. So when x is 2, so I would have 2 squared, y is equal to 12. And when they give you x is 1/2, so I would have 1/2 squared, what is y equal to? So then I have a cross multiplication. So I would have 12 over 4, so I would have 4y equals 12 times 1/4, which is 3. So y would equal 3/4 in that scenario. All right, and so then you would mark the 3/4, and then it gives you 2 opportunities to work on each problem. And then it just moves on. So you have to launch them, these scenarios, but you have to launch them, but it only gives you 2 tries, and then it moves on. All right, so here we have a little change in hours. All right, so they're taking from a military clock where you're leaving at 22:37. So anything over 12 is going to be p.m., so 1 o'clock, 2 o'clock, 3 o'clock. So 22:37, if I subtract 12, actually gets me to 10:37 p.m. And I land the next day at 9:20. So from 12 o'clock to I land, that's 9 hours and 20 minutes. And to get from 10:37 to midnight, so that gets me 43 minutes. Nope, it gets me 23 minutes to get to 11 o'clock, and then 1 hour to get to 12. So when I add those together, I would end up with my 10 hours and 43 minutes. And of course you would look at that and then pick that one and submit. The problems might be a little bit different, but they're basically the same concept. All right. Now this one asks you to complete a table. So it's looking for those particular table values. And you want to complete the table for the given function. Use the table to graph the functions on paper. So they want you to take 4 and put it into this value and then solve. So that one's pretty simple. You can use a calculator, and then you'd be graphing each one to remember asymptotes in that particular one, because here, remember, x can't equal 0. So here's my asymptote to this. Okay, so on your calculator, be very careful. You really can't see asymptotes on a calculator. Your calculator is going to show this, but remember, it is asymptotic to that. It can never take on that particular value. All right, so pick the value of the largest integer k so that the following equation has exactly one solution. So if I make this a little larger, so I have x plus 1 over 2x squared minus 1 equals k. You can do this several different ways. You can put in each value for x and make a table of values to get one solution. See, here's the problem with the solution there. It's because x can be squared. So if I put in 0, let's just take the values. Normally in a multiple choice scenario, that's going to be the quickest for you. So if I pick 0, I have an undefined function. So I can't pick that one. So I've already eliminated down to 3. And notice how I have 1, -1, and -2. Well, here I'm squaring it, right? And then I would subtract and add another negative. So I'm hesitant to pick that one. So if I picked 1, then I would have 1 plus 1/2 minus 1 equals k. So k in that case equals 1/2. And then I'm going to choose my -2 and see what happens. So I would have -2 plus, here I'm going to have a -2 squared, which gets me 4. 4 times 2 is an 1/8, minus 1. So here I'm also looking at a rather large negative number as opposed to the 1/2. And I imagine when I do that with the -1, I would put in the -1. But see, here I had to have a -2. So again, I'm having a smaller number. Probably not as big as small as the -2. So here I'm looking at that k equals 1/2. So in both these two knowledge checks, you're making a substitution and making a comparison. So here's another one, question 5. By drawing a suitable straight line on your graph, solve the equation below and select the approximate values of all 3 solutions. So again, we have x plus 1/2 squared minus 1 equals 4 minus x. Now I might rearrange this a little bit so that I could have some substitution. So if I move my x over here, I would get my 2x plus 1/2x squared. And then I'm actually going to move my 4 over to get a -5. And I'm going to set that equal to 0. What's interesting is then you can manipulate some of the areas of this particular function. It would have been a little bit easier if, but they never do that. So let's get rid of this fraction under here and let's multiply everything by 2x squared. And then what you can see in this is going to be 2x. And then this one's going to be 1. And then this is going to be 5 minus x, minus 5 times 2x squared. Let me just shove that in. 2x squared equals 0. So now what do I have? I have a 4x cubed plus, I'm going to do over here, a negative 10x squared. And then I'm going to have my plus 1 equals 0. Now I have a little bit more of an idea of how to solve this problem, because that to me is more of a function than that is. And remember, multiplying the 2x squared by, the beauty of it is having that 0 on the other side. You don't have to worry about it. Then I go into my ideas of how I can solve this. And there's a couple ways to solve it again. You are allowed to use your calculator, and that's probably the fastest in this particular one. All right. I can't use x equals 0. I can substitute these values in, but I can also use that polynomial idea of the first. So I have plus or minus 2, the factors of 2, and I have plus or minus the factors of the last one, so it's positive 1. All right, so I can use that P over Q to find out some of the values. But I would definitely graph this one and allow yourself a little bit more time to work on other problems. All right, but that would be getting some of the factors. All right, so what they're looking for, select the approximate values of all three solutions, is this idea is, I'm going to draw a cubic function. So I have this cubic function, this is not what it is, but I have this cubic function that intercepts at 3 different times, and that's what they're looking for, the solution. So you can take these values and plug it in and see if it actually does equal 0. That's one method. You could factor it, which probably a lot of us would not go through that, or you can graph it. And I think at this point, let's just graph it. All right, so we have this again. The following equation can be written in the form ax squared, which is really funny because that's what we did in the previous one, okay? So that gets you some of the values. So that's a correct one. Sometimes we do one problem and we solve another one. Okay, so this is like a similarity problem, only it has scaling. So in this it says use the scale of 3 centimeters is 20 meters. So we would have to convert the 9 centimeters and the 16 centimeters to the scale factor and then find the area. Or we can find the area and then change it over to the scale. Its preference is 6 of one, half a dozen of the other, but I like to do it before I start. So if I have 9 centimeters and I know that, I'm going to change the pen, my scale is 3 centimeters is 20 meters. I can then cross multiply, so I have 180 divided by 3. So here I would have 60 meters. Then I could take my 1.5 centimeters and do the same thing, 12 meters is to 3 centimeters, in order to get that 2 meters. Okay, so if I do 0.5 times 2, so I would have 10 meters. I believe that's correct. That's 35. Yeah. Then I would have 60 meters times 10 meters, and then I would get my meters squared. All right, so those are just conversions that are based on similarity. All right, here's a great one. This is a triangular similarity problem. And what you have to understand is the ratio. So they're looking at the ratio. Let me make this a little bit bigger. So this is based on this idea of parallel lines. So this angle and this angle are congruent, and angle A is congruent to angle A. So if I took triangle ABC, it would be similar then to triangle A, oops, this is ABE, and this is ACD. All right, then I could find my ratios, right? So I always go AB is similar to AE, which is similar to BE. So now I've taken care of my first triangle, the first and the second, the first and the third, the second and the third. And then I do it over again with the next one. A first and second, first and third, and now I can make my substitutions. I can replace my similarity with my equal signs, and now I can make my substitutions into my problems so that I'm able to continue and to solve the problem. For example, I know AB is 40, and I know AE is 32. Okay, and I can find different, what I'm looking for is AC, right? So I'm looking for AC. Well, if I call AC, remember I can do with expressions. Let's just call it AC is X. okay? And then I know other ideas, right? So BE, I've got, does that say 32? And then I've got this one, so I could make those substitutions, whatever it is. Now these are actual problems from the exam, so I don't want to solve them, but this is the idea of making that substitution. And remember that I can do one in terms of the other. Instead of saying if this is x, right, then I have this as the addition of this and this. So be careful with your numbers also. All right, so a certain drug is made using two ingredients, compound X and compound Y. There are 4 milliliters of compound X used for every 7 millimeters of compound Y. If a chemist uses 304 milliliters of compound X, how many milliliters of the drug are made? So in these, you have to look at them as two equations and two unknowns, right? You can also look at mixture problems. So if I have X and I have Y, and I can make a drug, D, okay? If there are 4 millimeters of X for every 7 millimeters of Y, okay? So I have this relationship now that they've given me. For every 4 of X, I have 7 of Y. So I have this ratio that exists for them. So if I use 304 milliliters of X, right? So if I have 4 millimeters of X, now I have an XY ratio in here. So if I look at just the relationship of X to Y, so 4X is to 7Y. And how much of X am I using? I use 304 of my X compound, and I know that that's equal to my Y. So my Y is going to be my 4 times my 304 divided by my 7. So I have that ratio, okay? So this is the relationship, right, for every X and every Y. Let's say in problem E, we have triangles A, B, C, and D, E, F are similar, such that E and D are points on segment AB, so that BE equals DA. So what does that mean? So I can call these both X. So what's the length of BE? Well, what's the length of BE? So what's the length of X? So what do I have? I have triangle ABC is similar to triangle ABC DEF. It's important the way that they named it. So if I know that AB and AC and BC, those ratios are going to stay the same when I have DE, DF, and EF. So now I'm making my substitutions. So let's just look. What is AB equal to? Well, we could say that AB was equal to 2x plus 7. And what's DE equal to? Oh, well, that's easy. That's 7. AC is equal to 20. DF is equal to 14. And really, BC and EF, I have no info, right? So I can just ignore that. And so now what do I have? I have a cross multiplication where I can solve for x. And what exactly is x? X in this case is going to be BE or DA. So those are really triangle similarity is all about naming it and all about understanding that relationship. And slightly out of order, but nonetheless a triangle similarity problem. So it says that RST is similar to QPT based on the additional information in the picture. Which of the following statements are true? All right, so what could we do? Well, we could solve for a whole bunch of things, right? We could set up our RS, RT, ST, and our QP, QT, and PT, right? And we can set up a whole bunch of things. We also know that in addition to this ratio, we have this idea that the angles match up. So angle R and angle Q are congruent. Angle S and angle P are congruent. Angle T and angle T are congruent, and they better be because they're vertical angles. Okay, so those are the types of questions that they're going to